Hello everybody, welcome to the Homework Helper for section 4.4. Doing it right every single time, no mistakes, we got this. All right, so for the ready section, this is a little bit of a review of some work that we've done before where what we're going to be doing is we're going to be finding the roots of a function, and then we're going to be finding the domain of its inverted form, right? So notice that f and k, these functions are just inverted, where we have our three binomials here, and then they end up in our denominator here. So for this one, we look at it, we see that our roots are when this equals to 0. So what would cause this to be 0? What would cause this to be 0? What would cause this to be 0? Then looking at whatever our roots are, which, you know, this would be -5, 2, and 7. Those numbers, when plugged into our bottom version, cause us to have gaps in our domain, specifically asymptotes for this version. But either way, it gives us a denominator that is 0, which is undefined. So pretty much the next few questions, 5, 6, and 7, are going to ask you to think about that relationship between the roots of a function and the domain of its inverse. Why are those numbers the same thing? What ends up going on there? All right. Let's go on to the next part, the set piece. Now the set piece is asking us about whether or not a rational function is proper or improper. So we need to think about what an improper and proper fraction are. And the definition of it is pretty simple. A proper fraction, or in this case a proper rational function, is going to have the degree of the numerator is going to be less than the degree of the denominator. Okay, so if the degree of the numerator is less than the degree of the denominator, we're going to call it proper. If the opposite is true, if the numerator is larger than the denominator, the degree, then we're going to call that improper. So here, let me say degree. So if this were like a degree 3 and this were a degree 4, this would be proper. But if the reverse were true, if this were a degree 4, this were a degree 3, this would be improper. Okay. So here, 3, 2, this would be improper. 3, x to the 0, this would be improper. 2, 5, this would be proper. Okay, that's pretty much all it's asking us to do. But it's going to get a little bit more complicated in the next section, because in the next section, it wants us to determine if each rational function is proper or improper. Okay, we were just doing that. But then if it's improper, we're going to use long division, or we could use synthetic division to rewrite the rational expression as it says a of x divided by b of x equals q of x plus r of x over b of x. Essentially what it's wanting us to do is to divide it, simplify it, and then write a remainder if there's a remainder. So let's go ahead and see what this looks like. Okay, so first of all, we need to see if it's improper or proper. This is large. This is a 3. This is a 1. So because the degree of the numerator is higher, this means this is an improper. And what does it want us to do if it's improper? It wants us to divide. So I'm going to use the two types of division that we know. I'm going to use long division, and I'm going to use synthetic division. You can use whichever one you want. And we're going to figure out what the answer is. I'm going to do long division on this sticky note here. Okay. So we're going to divide x minus 1 into 2x cubed minus 7x squared. But look here, there's no x term. This is pretty critical. So we have to actually write plus 0x. You know, that can be easy to miss, but every term needs to be accounted for. And then I'm going to write plus 6. Okay. X times what is 2x cubed? It'd be 2x squared, giving me 2x cubed minus 2x squared. I then subtract. This eliminates. Negative 7 minus a negative 2 is negative 7 plus 2. That's negative 5x squared. I'll bring down my 0x. What do I have to multiply x by to get negative 5x squared? That'd be negative 5x. Negative 5x squared. That would be plus 5x. I now subtract. This eliminates. 0 minus 5 is negative 5x. I'm going to bring down my 6. What do I have to multiply negative 5, or what, I'm sorry, what do I have to multiply x by to get negative 5x? That would be minus 5. Minus 5 is negative 5x plus 5. Subtract. This gives me 6 minus 5 is 1. So giving me a remainder of 1. So now that I have this as a remainder of 1, I need to get it to look like this, where I need to write the remainder over whatever I was dividing it by. So our way of writing this now as a proper fraction would be 2x squared minus 5x minus 5 plus my remainder, and my remainder is 1, so 1 over whatever I was dividing by, x minus 1. So that there would be our answer when we divide this improper rational function. Lots of steps in long division. Let me go over synthetic division one more time, and you can make the decision about whether or not which is easier for you. So for synthetic division, we have to do one quick step. So we're dividing by x minus 1. We need to set that for 0, set that equal to 0, and solve for x. So x equals 1. Great. So now that we know that 1 is our root, we put 1 outside of our synthetic bar. We write down our coefficients, 2, negative 7. There's still that 0x there, so I need to put the 0 there, and 6. This will be our remainder, this bottom corner here. I bring down the 2, I multiply, I add, I multiply, I add, I multiply, I add. Now I lower my degrees. So I started with x cubed, so this 2 is 2x squared minus 5x minus 5 plus 1 over whatever I originally was dividing by, x minus 1. And I believe that's exactly what we got here, right? Yes. So both long division and synthetic division will get you the right answer. You just have to make sure that when you're doing synthetic division, we were dividing by x minus 1. We need to set that equal to 0 first to get our root. Here it is our root that we are dividing by. Here it is the whole divisor. So you got to be careful to make sure that you don't mess up that little piece. But here we are. Here is our simplified version of 15. Now it's written as a proper fraction, with this as our remainder. Okay. Finally, the go piece. We're going to be stating the domains of the following functions. To find the functions here, we need to figure out where the holes in our domain are. So you want to be looking at your denominators to figure out where the holes in the domain are. You'll see here that because those reduce, the hole is at 2, but we'll have an asymptote at negative 5. We'll have a hole at negative 6, but we'll have an asymptote at 4. And then you can look at 21 to see how that works. It says for each of the previous functions that has only one vertical asymptote, write the equation of that vertical asymptote. So figure out which one has the vertical asymptote, write it as an equation, x equals. And then finally, 19, 20, and 21 are graphed here. So these functions are being graphed here. So given that we know holes in the domain, given that we know what the vertical asymptotes are, pair each graph to the appropriate function. Okay. Now, one of the things about this is we only get the asymptotes here, right? We only see the asymptotes. So we see here is the vertical asymptote at x equals 4. Here is the vertical asymptote at x equals negative 5. And here's the vertical asymptote at x equals 3. But it wants us to put an open circle on anywhere it is undefined. We want to put an open circle on the holes. So for example, Let's look at 19. 19, we knew that -5 would be an asymptote, and we knew that 2 would be a whole, because it's going to be undefined at 2 because that's where it reduces. So what I want you to do for number 19 is draw the line of the asymptote like I already did, but also at 2, draw a hole to show that that is where it's undefined. Okay? Do that again for number 20 and 21, and that'll do it. Good luck, everybody.